Hey guys, welcome back to the continuation of ionic equation, how to write ionic equation, what is an ionic equation. Some of the concepts related to ionic equation have been discussed earlier as well. In that topic, I have told it to you why to write ionic equation. That is to find out that which components are soluble out of the whole equation and which components are insoluble, what are the spectator ions. All these points have been discovered in the previous video. Here we can say this thing that barium hydroxide is reacting with nitric acid in equation number 2. This is the example number 2 for ionic equation. The first example we are done with that. It is the reaction of NaOH and HCl in the previous video. Here I am discussing about barium hydroxide and nitric acid. As a result, barium nitrate along with water will be formed. We know it very clearly that barium hydroxide is soluble. Okay, we are going to discuss its solubility. All oxides and hydroxides will be considered as insoluble except for the group number 1, ammonium family, and barium and strontium. Barium and strontium are the last elements of group number 2. Going down the group in group number 2, the solubility of oxides and hydroxides is getting higher. Okay, so it is barium hydroxide which is getting more soluble in water as compared to the top members of group number 2. So we are going to consider it as soluble. That's why we have written aqueous with it. What about the nitric acid? It is also soluble. All acids are soluble without any exception, so we are going to consider it as aqueous. And what about the nitrates? It is soluble, so we are going to consider it aqueous as well. And what about water? Water will be considered as insoluble. That's why it is written as liquid. Okay, so now we are now going to convert this barium hydroxide and nitric acid into its components. Barium is a part of group number 2, so it has a charge of +2, whereas hydroxide is a radical. It's a polyatomic ion, so it has a charge of -1. What about the nitric acid ions? It will be 2H plus 1 and 2NO3 1 minus. Again, nitrate is a radical. It has a charge of -1. H plus 1 will come for 2 times to cancel the charge of 2 nitrates. Okay, guys, I'm giving you a reminder again and again that in all ionic compounds, we should know this thing that components positively charged and negatively charged are combining in such a ratio that they are canceling each other's charges and the final compound has zero charge. Okay, so it will be 2H plus 1 and 2NO3 1 minus, and we can say this thing that Ba plus 2 is over here and 2NO3 1 minus is over here. In case of barium nitrate, we have converted these into their ions. And what about the water? It will be remain as it is. Now we are canceling the charges of canceling the charges on the components which are considered as spectator ions. Okay, we are going to select the spectator ions and we are going to cancel them. Okay, barium is in the ionic state after the reaction and before the reaction, so barium ions are considered as spectator ions. That's why they will be cancelled here. What about the nitrate? It is also a spectator ion. It is a spectator ion too, so we are going to cancel the nitrate as well. Now what is the remaining equation? It will be just 2OH 1 minus 2H plus 1 and H2O in the liquid state. So we can say this thing that these all are considered as a spectator ions and we are going to cancel them and the final equation will be written afterwards. Okay. If I am on the third example, that is for the barium sulfate formation. It is a reaction of sulfuric acid with barium nitrate to make barium sulfate, and the other product is nitric acid. Okay, we know this thing perfectly that all acids are soluble, so this will be considered as soluble. Nitric acid will be considered as soluble too because it is an acid as well. What about the barium nitrate and barium sulfate? All nitrates are soluble, so we are going to convert it into its ions. Now, the problem is with barium sulfate. Okay, so what about its solubility? All sulfates are soluble except lead, barium, and calcium. So it means that barium sulfate will be considered as insoluble. We are going to write solid with that. Remaining all three are considered as aqueous, being soluble. We are converting them into their ions. And afterwards, what happened? We have just selected the spectator ions. 2H plus 1 is spectator ion on the both sides of the equations. It is present in the ionic state, so it will be cancelled. What about the nitrate? It is also a spectator ion because it is present in the ionic state before and after the reaction. So we are going to cancel it. Now the problem arises with barium ions and sulfate ions. These are in the ionic state before the reaction, but not in the ionic state after the reaction. So they will not be the spectator ions. They will be written as it is. Okay. So we are now going to write the sum up equation, the resultant, the final equation. It is Ba2 plus SO4 2 minus and BaSO4. So this is how we have written the ionic equation for the barium sulfate formation. Okay. Now we are on the fourth example. It is for AgCl formation. AgCl is also considered as insoluble. How we know this thing? All chlorides are soluble except lead, silver, and mercury. So lead chloride, silver chloride, and mercury chloride are considered as insoluble. What is the symbol for mercury? It is Hg. And what is the symbol for mercury? Hg. And what is the symbol for silver? It is Ag. So please differentiate between the two and make the difference very clear in your mind as well. Okay. So for example, we are preparing AgCl from the two partners. One of them is ammonium chloride, whereas the other is silver nitrate. Okay. After the reaction, they are going to produce silver chloride and ammonium nitrate. Silver chloride and ammonium nitrate. Now, afterwards, after silver chloride is being produced and ammonium nitrate is being produced, we are going to convert the soluble ones into their components. All ammonium compounds are soluble in water, so that's why we have converted them into its ions. It is going to convert itself into ammonium ion and Cl1 minus ion. Guys, don't forget ammonium ion is also one of the polyatomic ions. I am asking you again and again to keep the polyatomic ions list in your mind. This will be very helpful to you while developing the formula. And ammonium chloride will be converting it into components. We have written the components here. They will be in the aqueous state. That's why we are writing it here. Okay. What about the silver nitrate? Silver nitrate is soluble in water as well. So we are going to convert it into two components. One of them is silver ions and the other is nitrate ions. When we are writing for AgCl, AgCl will be considered as solid, so it is written as it is. What about ammonium nitrate? It is going to convert itself into two types of the ions. One of them is ammonium ions and the other is nitrate ions. Then we are going to select the spectator ions on the both sides of the equations. They will be cancelled and the final equation will be written as it is. Okay. So this is one of the way I am practicing again and again so that you people may have a better acquaintance towards the ionic equation. Few more examples are there as well. It is the equation between Cl2 and Ki reaction. Cl2 is considered chlorine being insoluble and potassium iodide is considered as soluble. Why it is so? Because potassium compounds are soluble in water. This reaction is a displacement reaction. Why? Because Cl2 is more reactive as compared to I. Hence, Cl2 is going to replace I from its compound. It is going to make its own compound and I2 will become out of the compound. Okay, it is related to the reactivity in group number 7, which we have studied in the topic of periodic table earlier. Okay. Now I am telling it to you that Cl2 will be considered as insoluble, whereas Ki is going to convert itself into its ions. I can write the word of gas here, that is Cl2 gas is bubbled through Ki solution. So it is a gas here, and we may say this thing that it is a liquid, or you may say that it is a solid here. It will be settled at the bottom, whereas all the ions are always in the aqueous state. There is no other option for any ion. Okay. I2 might be in the start, it is in the liquid state, but getting converted, or you may consider this thing that at the start you may say that it is forming in the vapor form and finally it is settling at the bottom, but we can overall consider it in the solid state. So here it is in the gas state again, and these are the aqueous ones, and these are the aqueous one here as well, and the solid here, and this is the aqueous here and aqueous here. We are going to convert the aqueous ones into their components. It is K plus 1 ion, which is in the spectator ion, which is being cancelled on both sides of the equation. This is one of the important equation regarding the displacement reactions of group number 17, group number 7 as well. There is another reaction, guys. This equation number 7, I'm making a star with that as well. This equation has been asked for the MCQ paper for many times, many times. So please be careful about that. It is calcium carbonate. It is no doubt reacting with HCl. It is soluble in HCl, you may say, but itself it is insoluble in water, so we are not going to convert it into its components. After reaction, it is converting itself converting itself into the same form. So there is no change in the calcium carbonate formula. It is not going to convert itself into its ions. What about the HCl? It is converting itself into H plus 1 and Cl1 minus, which we have seen here. And the CaCl2, all chlorides are soluble except lead, silver, and mercury. That's why CaCl2 is going to convert itself into Ca2 plus and 2Cl1 minus. Afterwards, carbon dioxide and water will be considered as insoluble. Hence, we are going to write them as it is. So it is CaCO3 and 2H plus along with Ca2 plus CO2 and H2O will make a combined ionic equation for the reaction between this calcium carbonate and HCl. Okay. Afterwards, there is another equation for the zinc oxide and sulfuric acid making zinc sulfate and water. It is again the sulfate ions which are considered as the spectator ions. Zinc oxide is insoluble. Why zinc oxide is insoluble? Because all oxides are insoluble except for the oxides of group number 1, oxides of ammonium. So in this way, zinc oxide will be considered as insoluble. We are going to take it as it is. Okay, so then there can be another example as well. It is Cl2, which is considered as gas here, and along with 2NaOH, so it is going to make 2Na plus 1 and 2OH1 minus. Okay, and it is making here the product is NaCl, so it is Na plus 1 and Cl1 minus. Along with that, it is making Na plus 1 and ClO1 minus and H2O as well. So here the spectator ions is Na and Na here. So the remaining equation will be Cl2 and 2OH1 minus, along with that Cl1 minus and ClO1 minus and H2O as well. Okay, so this is the equation along with the spectator ions which I have written here. This is just telling you that all the time we have to categorize that which are the soluble ones and which are the insoluble ones, convert the soluble ones into their components, cancel the spectator ions on both sides of the equation, and write down the sum up equation at the end. Okay, guys, I would like to continue a few more equations here. I have just 3 more examples for you. I would like to solve those equations. I would like to react Cl2 with the NaOH and another equation as well. And then you people can learn better for the ionic equation, inshallah. Take care of yourself. See you in the next class.